Hey everyone, ever looked at a chemical formula like C6H6 and wondered, is this a ring? A bunch of double bonds or both? Today, we're cracking the code on the degree of unsaturation, also known as the double bond equivalent. By the end of this video, you'll be able to look at any molecular formula and instantly know its structural secrets. Let's dive in. Ever wonder why some fats are called saturated and others unsaturated? In organic chemistry, the secret lies in the number of hydrogen atoms. Let's break down the degree of unsaturation using a simple analogy, a city bus. Let's see saturation. First, think of a saturated hydrocarbon as a bus at maximum capacity. Every single seat is filled with a hydrogen atom. In chemistry terms, this means the molecule has only single bonds and follows the golden formula, CnH2n+2. If the seats are full, the bus is saturated. Unsaturation. Now, look at the unsaturated bus. It has empty seats. This happens whenever a molecule has double bonds or forms a ring. Because those structural changes take up space, you have to remove hydrogen atoms to make them fit. Specifically, every time you add one double bond or one ring, you lose exactly 2 hydrogen atoms. The degree of unsaturation. This brings us to the degree of unsaturation, or DO. Think of one DO as one pair of missing hydrogens. If you see one double bond, that's one DO. If you see one ring, that's also one DO. By counting these missing pairs, we can quickly sketch out the skeleton of a mystery molecule. So, remember, saturated is a full house. Every missing pair of hydrogens tells you there's a ring or a pi bond hidden inside. It's like being a molecular detective. When molecules get complex, eyeballing the structure isn't enough. You need a fail-proof tool. That's where the golden equation comes in. Don't let it intimidate you, it's just a simple balancing act of atoms. The equation. Here is the formula to memorize. DO equals 2C plus 2, plus N, minus H, minus X all divided by 2. It looks like a mouthful, but let's break down those variables so they make perfect sense. The variables, first, C is your number of carbons. You multiply this by 2 and add 2 to find your baseline saturation. Next, look for N, or nitrogens. If you have them, add them to your total. Then, we look at the H group. Subtract your H, the number of hydrogens. You also subtract X, which represents halogens like fluorine, chlorine, bromine, or iodine. Think of halogens as hydrogen mimics, they take up a spot, so we treat them the same way in the math. Here's the best part. There are 2 elements you can ignore entirely. If your molecule has oxygen or sulfur, just skip them. They don't change the degree of unsaturation, so they don't even get a seat in the equation. Plug your numbers in, divide the final result by 2, and you've got your answer. It's the fastest way to turn a chemical formula into a clear mental picture of a molecule. Ready to see it in action with an example? Let's put that golden formula to work with a classic example, benzene. Its chemical formula is C6H6. Looking at it, you might wonder how those 6 carbons and 6 hydrogens fit together. Let's solve the mystery step by step. The carbon calculation. Step 1. Look at the carbons. We have 6. Using our formula, we calculate 2 times 6 plus 2. That gives us 14. This number represents how many hydrogens a perfectly saturated 6-carbon chain should have. The subtraction. Step 2. Look at what we actually have. Benzene only has 6 hydrogens. So, we subtract those from our ideal number. 14 minus 6 equals 8. This means benzene is missing 8 hydrogen atoms, or 4 pairs. Step 3. Divide that result by 2. 8 divided by 2 gives us a degree of unsaturation of 4. But what does that 4 actually look like? If you check the structure of benzene, it all clicks. It has 1 ring and 3 double bonds. 1 plus 3 equals 4. The math and the molecule match perfectly. And there you have it. Whether the molecule is simple or complex, the formula never lies. Now you're ready to tackle any structure that comes your way. The final result tells you exactly what you can't afford to build in your molecule. Let's look at your cheat sheet. If your DO is 1, you have 2 main options. You can have 1 double bond, like an alkene, or 1 ring, like a cycloalkane. Either one of these structural features costs exactly 1 pair of missing hydrogens. A DO of 2 gives you more variety. This could mean 2 double bonds, a dene, 2 separate rings, or 1 triple bond, an alkyne. A triple bond is a double unsaturation because it contains 2 pi bonds. Finally, if you see a 4 or higher, that's a huge hint. A result of 4 almost always points to a benzene ring. Why? Because a benzene ring is made of 1 ring plus 3 double bonds. 1 plus 3 equals 4. It's a very common package deal in organic chemistry. Use these numbers as your guide. The formula tells you how many features you have. The cheat sheet tells you what they likely are. Happy building. So, before you go, keep these 2 things in mind. 1. Halogens are hydrogen mimics. Because they only form 1 bond, they occupy a spot where a hydrogen would usually be. That's why we subtract them in the formula. 2. Oxygen is invisible. Oxygen forms 2 bonds, so it literally inserts itself into a chain without changing the hydrogen count. Just skip it in your math. And that's it. You've just mastered one of the most useful tools in organic chemistry. If this helped you clear the brain fog, hit that like button and subscribe for more chemistry shortcuts. Thank you.